Okay, this is example 4, an ellipse, and our equation here is 4x squared plus 9y squared equals 1. Because x squared, x and y are both to the second power, and we have they're both the same sign, it looks like the equation will represent an ellipse, and we want to try to match it to this form here, x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. And this is actually close to that form. We already have the equals 1, we already have the x squared and y squared, and we just need to get these numbers on the bottom. We need to get rid of these numbers here. So a whole number can be written as a fraction if you put it over 1. So we can put these over 1 to make these into fractions. And then in order to get the fourth out of the numerator, we can multiply top and bottom by the reciprocal. So we want to multiply top and bottom of each fraction by the reciprocal of the coefficient. So for the first term, we're multiplying top and bottom by 1/4. And then for the y term, we want to multiply top and bottom by 1/9. Yeah. Okay. Okay. So the 1/4 times 1/4 is 1. That'll cancel. It's a little messy here. And the 1/9 times 9 times 1/9 will cancel, and that will leave us with just x squared over 1/4 plus y squared over 1/9 equals 1. And now it's very close to the form that we wanted in. 1/4. Okay, so it's very close to the form that we wanted in now. We just instead of the x, we can write x minus 0 instead of y, write y minus 0, and then we want to write the denominators in exponent form. Square root of 4 is 2, so this is going to be 1/2 squared on the bottom, and so that'll give us the formula. To rewrite this, we'll have x minus 0 squared over 1/2 squared plus y minus 0 squared over 1/3 squared equals 1. And now it exactly matches the form that we wanted. We have the form that we want is x minus h squared over a squared plus y minus k squared over b squared equals 1. And now we can identify h, k, a, and b. H is going to be 0, k is 0, a is 1/2, b is 1/3. So it's going to be an ellipse. The center, hk, that's going to be 0, 0. 0, 0, and for the from the center, if we go left and right from center, 1/2, a is 1/2. That'll give us the vertices. So it's the vertices are going to be go 1/2 to the left, will be negative 1/2, comma 0. And if we go 1/2 to the right, that will be 1/2, comma 0. Okay, that's going from the center, left and right. And if we go up and down from the center, we'll get the co-vertices. The vertices are in the longer directions because A is bigger than B. 1/2 is more than 1/3. The vertices will be in the x direction. The co-vertices will be in the y direction. So the co-vertices would be 0, comma negative 1/3 and 0, comma 1/3. And then we can draw the ellipse. We can make a little table of values here. Let's see, we have x, y. we have negative 1/2, 0, 1/2, 0, 0, negative 1/3, 0, 1/3. So negative 1, 1, 1, 1, x, y. Okay, so the center is 0, 0. And then from the center, if you go 1/2 to the left, I'll get a vertex. 1/2 to the right, 1/3 up, 1/3 down, and then connect the dots, and that gives us our ellipse. Okay. And then for some purposes, it's important to identify the foci of the ellipse. Foci are going to be along the major axis. There'll be one about right here and one about right there. And they're important in some applications. For example, the Earth's orbit around the Sun is a elliptical orbit, ellipse shape, and the Sun is at one of the two foci. So anyway, there's a formula for computing the foci. We first have to get C. By the way, the major axis connects the two vertices. Minor axis connects the two co-vertices. And then the foci are going to be on the major axis. We want to first compute C. So this is going to be square root absolute value a squared, which is 1/2 squared, minus b squared, which is 1/3 squared. So this is going to be half squared. We have 1 squared. 1 times 1 is 1. 2 times 2 is 4. So it's 1/4 minus 1/9. And then we need to get a common denominator. Multiply top and bottom of the first fraction by 9. We'll get 9 over 36 minus, and then multiply top and bottom of the second fraction by 4. We get 4 over 36. Want the absolute value of that. So the square root of absolute value of 9 minus 4 is 5 over 36. Square root of the denominator, we can take that. The square root of 36 is 6. So this is going to be square root of 5 divided by 6. So we can take that outside the square root. So a square root of 5 is a little bit more than 2. 2 squared is 4. So so it'll be maybe something like 2.2, 2.3 or something. A little bit more than 2 will give us the square root of 5. So we can estimate, for purpose of graphing, square root of 5 is a little bit more than 2. So C is going to be a little bit more than 2/6, which reduces to 1/3. So the foci are going to be along the major axis. It'll be a little bit more than 1/3 in either direction. In a coordinate form, the foci are going to be square root of 5, negative square root of 5 over 6, comma 0, and positive square root of 5 over 6, comma 0. And that concludes this presentation.